Hello, and welcome to today's American Train Co. web conference titled The New Changes in 2015 Edition 70E. During the presentation, all lines will be in a listen-only mode. You may submit a question to our speaker at any time by clicking in the text box at the bottom of your screen. Type in your question, then hit the Send Question button below. Questions will be answered in the order they are received at the end of the presentation. Today's speaker is Bob Kluke. Bob brings over 35 years of practical electrical experience to his students in every class he teaches. Bob has been with American Train Co. since 2007, and in that time he has become one of the finest instructors we've ever had. Not only is Bob a licensed master electrician, but he is also a certified NCCER and OSHA instructor. In addition, he is a member of the National Fire Protection Association and the International Association of Electrical Inspectors. Thank you for your attention. I would now like to turn the conference over to your speaker, Mr. Bob Kluke.
Thank you so much, everyone, and welcome to this presentation on the 2015 edition of 70E, the new changes that we will be impacted on. So, as Kellen said, my name is Bob Kluke, so we'll entertain all questions at the end of the presentation. He did give you a little bit of background about myself, so all the bullets that are coming up are pretty much what he had talked about, so we'll take that as it is and get right into the changes. So, this edition of the 2015 70E was voted on in June in Las Vegas at the NFPA's annual conference, which I happened to attend, so I had some pretty good quality input on some of these changes. It was issued on July 14th and effective date of July 29th. Supersedes that 2012 and all previous editions, which date all the way back to 1976, was the first 70E that the NFPA issued. And we will see that they have made some major changes here, one of which is that everything that dealt with analysis is now going to be a risk assessment. So if we had to perform an arc flash hazard analysis in 2012, it is now going to be an arc flash risk assessment. This is going to be a major impact, and we're going to talk about this in some slides that will be coming up. But it doesn't matter what the hazard is, we are going to do a risk assessment. They have put a new annex in the back of NFPA 70E to give us some guidance on how to perform these risk assessments, and we'll be talking more about them as this presentation continues. So, some new definitions for sure, especially because of the terminology of risk and risk assessment taking the place of analysis. So, some new definitions were added to Article 100, and there were some definitions that were deleted. But all these analysis terms will be going to risk assessment, and there will be a procedure for us to follow with this, and we will go ahead and take a look at that as we continue. So here's the risk assessment procedure. It does have to be included into the electrical safety program, and of course we're going to have to first identify the hazards. So we've got to take a look at the piece of equipment that we're about to approach, and we have to make a determination: is there any shock, arc flash, or arc blast hazard? At the same time, we want to really identify all the hazards, the mechanical hazards, chemical, whatever else there might be. Then we've got to assess the risks. So they give us, in that Annex F, they're going to give us a method how to do that. There will be a table there to give us an idea that if there is exposed energized conductors or parts, what the risk might be as far as shock or arc flash is concerned. And then they really want us to do some type of control to control these hazards, and they give us a hierarchy that we're going to be able to use, and that is going to look a little bit like this. So this was based on another standard out of the ANSI standards. So first of all, they'd like to have us eliminate the risk. So number 1 and 2, elimination and substitution, usually that would be included in engineering controls. So For example, if we're going to eliminate a risk, I'll give you an example of that. Maybe we have an operator that one of his tasks is to reset an overload. He has to go ahead and open up the control panel and put his hand inside where there is definitely some exposed energized conductors and parts, and he has to press a reset to have his machine back up and running again. Well, if we want to eliminate that risk, we'll locate that reset function on the outside of the panel so that he does not have to open that up, and he will not be exposed to any type of hazard then. There'll be no shock hazard, no arc flash, no arc blast, because there will be no energized exposed conductors or parts. And there's other things we can do. Maybe on our switchgear or our MCCs, there could be some exposed bus bars. Maybe we could go ahead and close them with plastic to maybe do that. And that's all going to be under some type of engineering control to do that type of elimination. Also, they really want us to have an awareness, so training is going to become extremely important. We're going to have to train on the hazards and make sure that the qualified electrical worker is aware of what it is they're facing on any type of particular piece of equipment. And administrative controls, maybe we'll be putting up some better type of barriers or better type of procedures to make sure that we are not allowing the unqualified person close access to this equipment. And finally, they're going to, our last form of defense is and always has been the PPE that we would put on to try to protect us from those hazards. So, in informative Annex F, there is a great little guide and an example of how to perform this risk assessment. And this is pretty much every time we approach a piece of equipment. So we want to go through those steps. Maybe we can identify the hazards before we, interact with the equipment. And then once it gets in place, we might be able to put some type of laminated sheet up there on the procedures used for that piece of equipment based on the risks and how we're going to control those risks. These are global changes, so that means they affect the whole document. So we would see this in definitions for sure, in Article 110, the general requirements, up in Article 130, where we approach energized equipment. So global changes throughout the whole document as far as any type of risk assessment is concerned. Okay. Also, they really wanted to stress upon us the importance of maintenance. So some safety-related maintenance requirements and other controls were added to the scope, and we're going to see that this will include additional training and especially auditing. So auditing is going to be very important because if we actually are practicing the safe work procedures, but we have not audited that, we have not documented it, then it becomes a moot point. We have to have documentation, we have to have forms in place that the training was given and the training was understood by the qualified worker, and we're going to go out and audit that, and that was placed in the scope of this document to really give us an idea that the NFPA technical committees believe that training and auditing are extremely important. So they put that in the scope of the document to impact all of the 2015 NFPA 70E. As I said, there were some definitions that were deleted out of Article 100. This definition was in the document ever since 2004. It really applies to high voltage line techniques, so they deleted this. It's better referenced in another standard, the NESC, which IEEE publishes. So this definition was deleted out of the document to sort of take care of any confusion that the basic maintenance electrical worker is not going to use this technique. So this was deleted from that document. The definition for qualified person was revised, and it was also revised in OSHA 1910 General Industry Standards, so they wanted to make sure this was correlated and that it did match up into 70E. Extremely important that they inserted the word demonstrated. There's some people out there very good at maybe looking up information. Maybe they can pass a license test. Maybe they can come into an interview and their speaking skills are outstanding. Well, the previous definition did not have that word demonstrated in there, so to be a qualified person, not only are you just going to talk the talk, but you've got to actually demonstrate that you can perform that work safely and that you do have an understanding of the equipment that you're working on, how it was made, how you have to operate it, how it was installed, and that you have received safety training, documented safety training, so that you can identify any hazards associated with that equipment and that there is a procedure in place to avoid those hazards. So this definition will go through all of the NFPA standards. The 2015 70E was the first one to get it. We will see in the 2018 National Electrical Code it will come into that. And the word demonstrated is very important. So there should be a hands-on component to any type of training so that the person involved can actually demonstrate their skills and give us an idea, that they can perform that work safely. The definition of prohibited approach boundary was deleted, and so that is a shock protection boundary. We had 3 shock protection boundaries in the 2012 edition of 70E, and they were a limited approach, which was the farthest one out, and then we had restricted, which started getting closer. The prohibited approach boundary actually was that we were making contact either with our meter or with a 1,000-volt rated tool. Well, the other 2 boundaries, they triggered something for us. The limited approach boundary triggered that no unqualified people could approach any closer than that distance, especially unless they were escorted by a qualified person. So that limited approach boundary was a nice trigger for us. It kept the unqualified people away, and they could not get any closer unless escorted by a qualified person. So that was good. The restricted approach boundary triggered all of our PPE was on. We had 1,000-volt rated tools in our hand, and that we had the proper category of meter in our hand. So that triggered something also. The prohibited approach boundary, in the eyes of the technical committee, did not trigger anything really. So they said there's really no need for that boundary anymore, so it was deleted from our tables. Also deleted from the Article 100, the definitions. So no longer any prohibited approach boundary. As I stated before, the electrical safety program now has to include some condition of maintenance for the electrical equipment that we're about to approach. So notice it says normal operation. Well, we got to get a handle on this. Normal operation of electrical equipment says shall be permitted where all the following conditions are satisfied. Well, the equipment is properly installed. Most electrical equipment that I encounter has been properly installed. It was installed under the National Electrical Code of the cycle that the installation took place. The installation is usually inspected. A permit was pulled, and some outside authority having jurisdiction came and stated, yes, that was properly installed. So that one can be handled pretty good. The next one, the equipment has been properly maintained. Well, this is going to be according to manufacturer's instructions, so a lot of our equipment probably is not going to fall underneath this particular requirement. The equipment has been properly maintained. Even if we took just a regular molded case circuit breaker, the chances that we properly maintained that circuit breaker over the years is probably pretty slim. So they're going to want documentation of this. So immediately, if we can't document that the equipment has been properly maintained, well, normal operation is not going to happen. So what does that mean? Well, that means that now we are going to have to wear some type of personal protective equipment to protect us from either shock, arc flash, or arc blast to operate that equipment. And you know, so that's going to be another example I might be able to give you on this. Normal operation of electrical equipment. A single pole switch, wherever we work. Well, we walk up, really, there's no real maintenance of that single pole switch. I mean, we might take a visual look at it, and if it's intact and nothing broken, the handle's still there, we're going to operate that with no PPE on. Okay, so that's normal operation. Well, I get to, let's say, injection molding equipment, and I'm going to operate the circuit breaker that controls that equipment. Well, that circuit breaker probably has not been exercised every year. Maybe it has not been megged out. Maybe it wasn't torqued correctly over the years. So proper normal operation is not going to happen on that. We would have to put the PPE on that involves that piece of equipment and make sure that we operate it with some protection on us. Number 3, the equipment doors are closed and secured. Easy to make sure that happens. All equipment covers are in place. That's good. No evidence of impending failure. So we're going to have to take a little bit of history of the equipment. Has there been some arcing involved over the years? And if we can satisfy these 5 points, then really there's no PPE that we have to put on to operate the equipment, because there are no exposed conductors, there's no exposed energized parts, really no evidence of that there is going to be an arc flash, arc blast. So if that is the case, we can operate the equipment normally, and but otherwise we're going to have to put some personal protective equipment on to just operate the equipment, to turn something on and off. They did give us an informational note on this to give us an idea of what I just explained. Properly installed, accordance with applicable codes and standards. Usually the National Electrical Code is the one that we would be looking at. Properly maintained, the equipment has been maintained in accordance with the manufacturer's recommendations. Many times those manufacturer's recommendations and installation instructions, those might somehow get put in a place where we can't find them, let's say. And so we're going to have to make sure we have some type of engineering notebook. We're going to have those recommendations in place, maybe a checklist that they were all followed in the course of the life of the equipment, if we want to operate the equipment in a normal operation. Evidence of impending failure, arcing, overheating, loose parts, maybe the original equipment is not there anymore and we substituted it with something else. So when we look at this evidence of impending failure, we better make sure the equipment has all the original hardware there and that it has been properly maintained over the years, and then we can operate it normally with no PPE. Otherwise, put the PPE on and operate that equipment. Audits. So, generally speaking, our electrical safety program, we have to audit that electrical safety program once every 3 years. But the electrical safety program has a component in there that says field work has to be audited every year. So that cannot exceed 1 year. So we're going to have to go out in the field. We're going to have to audit our qualified electrical worker to make sure that that worker is following all the safe procedures that we have in our safety program. We're going to have to make sure that the proper PPE is on, that we're doing lockout, tagout the way we should be, that we are doing our visual verification to establish that electrically safe work condition. So probably another form will have to be generated here so that we can perform this audit. And this doesn't mean that we have to audit every single worker out there, but we do have to go out and audit field work. We can go out on the manufacturing floor or go to the site that our worker is at that particular day if they are an outside contractor. And we're going to have to make sure that they are following NFPA 70E, and we're going to have to document that and put that in our files. OSHA is going to want to see that in the event that they do arrive and want to take a look at all of your documentation. Another change that was in Article 120, and Article 120 is establishing that electrical safe work condition. This is step number 6, when we have to install ground straps in the event that there might be any type of chance that the equipment can become re-energized, either with induction or with capacitance. Then we're going to have to install these ground straps. So they want to make sure this is part of our job briefing and our job planning, where we're going to install these, so the location, what size the ground straps are going to be, and how we apply them for our temporary grounding of our equipment that does have a chance of being re-energized through induction or capacitance. So this will all have to be in our job briefing. Okay, so here's a major change I want to say that, and this has been in 70E for as long as I can remember, since the 2004 edition, and they have stressed it at technical committee meetings, they've stressed it at seminars, but the document itself really had to be rewritten a little bit so that we can understand that there are 2 ways to apply a label to equipment. We can use the incident energy analysis, or we can use the PPE category method. Okay, so we have 2 choices here. We can do the full-blown analysis. Usually we'll have a team of engineers come in. They will be using software that is going to collect a lot of data. It's going to determine the fault current at each piece of equipment, the clearing time of the overcurrent device. So that's the analysis method. Or we could use the table method. They gave us a choice of doing this all the way since 2004. So we can use either method, but we cannot use both methods on the same piece of equipment. This is also going to be reflected on the label that we're going to see in a little while. So if we're going to do the incident energy method, then we're going to see a number in calories per centimeter squared. That is the number that we're going to have to protect ourselves against. If we are going to use the PPE category method, which a lot of people call the table method, then we are going to see a PPE category, 1, 2, 3, or 4. And you can use either method. That's your choice. But you cannot use both on the same piece of equipment. And that label is going to reflect that, and we're going to see that coming up. So here is the label, and we can see this label, and on this label we can see that it does have 3.8 calories per centimeter squared, so that was generated by the analysis. So somebody did an incident energy analysis, and they came up with a number of 3.8 calories per centimeter squared. What we should not see on this label is Category 1. So we should not see the table method in conjunction with the incident analysis. So we have to choose one method or the other. They have spelled it out for us in 2015. Use one method, but not both. So let me give you an example of where that might be a little bit of a conflict. We do the incident energy analysis method. Great. We put on the label the number of calories. Let's say it's 8.3 calories. Okay, I can go out and buy a long sleeve arc-rated shirt that would take care of 8.3 calories. It could be rated at 10.1 calories. Same with my long pants. I could get 10.1 calorie rated pants. But when that label says 8.1 calories, if I used the table method, and if we put category 3 on there, which would be the equivalent table method, my shirt and pants don't cut it anymore. I have to have a full-blown flash suit on, which is a direct conflict between having the calories on there and the clothing I have to wear to protect myself. So they have told us, you pick one or the other, don't mix and match, and that is the method that you are going to use. This really points it out very well. Here we can see the arrows are pointing to 3.1. That is the analysis method. The PPE category method is category 1. You can do one or the other, but not both. So the label is going to have to reflect that. And, of course, the 2015 70E is already being enforced. So we're going to have to take a look at our arc flash analysis method. We have to review that every 5 years. If we do find a conflict with the label, they would like to have us update the labels. So you're going to have to take a look at your labels and see if in fact you do have both of these methods listed on the label. So depending on the software that was used or how the electrical engineer decided to generate their labels, you might see this on some of your labels out there. As the labels are reviewed, we're going to probably, if it's an analysis method, only see the incident energy on the labels. We won't see a category on there going forward. Okay, now they give us an idea about that reviewing of that and who's responsible to put these labels on. So we'll take a look at that. These field-marked labeling requirements, they've revised these every year that a new 70E comes out, they're revised. And so when we do the hazard risk assessment now, which is what it's going to be called, the arc flash hazard risk assessment, will not be called the analysis anymore. If it identifies that the label is inaccurate, they do want us to update the label, and it tells us who the responsibility of this field mark label is. So this is definitely the responsibility of the owner of the electrical equipment. So if let's say we're an outside contractor and we happen to come to a mall, well, the store inside that mall might not be the owner of the electrical equipment. Whoever owns the mall owns the electrical equipment. Stores come and go. Malls stay where they are. So the owner of the electrical equipment is actually the mall. So the person that's going to be responsible for installing that label in that particular instance would be the owner of the electrical equipment. It would be the mall themselves. A lot of times in the manufacturing world, we work in a building and the owner of the company actually owns the equipment, so they would be responsible for that. But there are going to be times when the owner of the equipment is not the person that's inside that particular premise. So the owner is going to have to make sure that that label is installed and it's perfect in one method or the other. They also gave us an idea that inside that restricted approach boundary, we cannot wear anything that is conductive. So they added some additional text there. We're going to have to make sure that anything that is conductive comes off our body before we go inside that restricted approach boundary. And that is up in Article 130.6 also, so we want to make sure that that is something that's inside of our electrical safety program going forward. Okay. The tables. So as we decide which method we're going to use to generate our label or keep our workers safe, if we're going to use the table method, which is now going to be called the Arc Flash PPE Category method, then these have been revised. They have some separate tables for AC and DC, and they're going to list the task out. We've got to make a determination the condition of the equipment. So we've got to answer some questions before to be able to use these tables. There's going to be a yes and no format to do this, and the table is going to determine, are we going to need Arc Flash PPE or are we not going to need that? So that's going to be very important. Also, they put in for us some new shock tables, and those were revised, and we will see that the prohibited approach boundary is not going to be on those shock tables anymore. All right, so that was also taken into consideration. And hazard risk category 0 has been removed from those tables. So in 2012, we had 5 Arc Flash PPE categories, going from 0 to 4. In 2015, we now have only 4 Arc Flash PPE categories. Hazard risk category was removed. They felt that when the incident energy was below 1.2 calories, the chances of an arc flash occurring were so minimal that no arc flash PPE was required there. So with that reasoning, why would we ever put an arc flash PPE Category 0 on a table when there really was no arc flash hazard there to begin with anyway. So they deleted hazard risk Category 0 from those tables. No longer will be there at all. Also, we'll take a look at these tables, and we'll try to get a good handle on how we're going to answer these questions. We're going to give you a snapshot of these tables. We didn't include every single piece of equipment that NFPA 70E has in their table 130.7C15 because we just don't have enough room on these slides, but we're definitely going to give you a snapshot of these tables and give you an idea how to use these tables when you're out in the field. So if you walk up to a piece of equipment and you have no label on that equipment whatsoever, these tables are going to be extremely important on how to protect that qualified worker when he approaches that piece of equipment. So they did remove hazard risk Category 0. We have stated that because really no arc flash hazard requirement there at all. So let's take a look at these tables a little bit and see how they're going to work with the new 2015. So first, the shock boundaries. So these are AC shock boundaries. You can see we have no prohibited approach boundary there anymore. That was deleted completely. So the prohibited approach boundary will be gone. They did make a slight change to these tables also as far as the voltage range is concerned. So in 2012, we still had less than 50 volts, pretty much no rules if the equipment is going to be safe. We didn't have to worry anything about shock. We didn't have to wear gloves. And the same thing here in 2015. There is no limited approach boundary, no restricted approach boundary. If we're below 50 volts and the equipment is safe, then we don't have to worry really about any type of shock protection there. The next boundary, though, 50 to 150 volts. In 2012, that range actually went from 50 to 300. So what they're doing for us here is they're giving us a chance to work on 120 volts a little bit with, in reality, no arc flash PPE required, especially on 120 volt control circuits. The belief, especially from IEEE data that we found, is that 120 volts is not enough voltage to sustain an arc through the air. It's not going to ionize the air. It's not going to turn the air into a plasma. We're not going to see a fireball. We're not going to see the copper get heated up to 1,981 degrees, and we're not going to see it vaporize. So the tables are helping that with us a little bit. And all they're doing on the restricted approach boundary is basically telling us don't touch 120 volts. So we just have to be careful in that area. When we get up into the 208 three-phase and 480 volt three-phase range, we can see now that the restricted approach boundary did come back, and we are going to have to make sure we do have shock protection on for that particular area. But they did give us a little bit of leeway with 120 volts. So, and they did also give us an idea that 208 volts, we want to make sure we do know we have that restricted approach boundary there. So they played a little bit with the shock boundaries for AC. And here's the one for DC. Very similar, except under DC they did have their label go all the way up to 300 volts for DC, with the restricted approach boundary saying avoid contact. So pretty much no restricted approach boundary there, just don't touch it up to that level. And then the restricted approach kicks in when they get above 301 volts for DC. And these are both shock protection tables. They have been revised a little bit, especially the biggest one that got taken out was the prohibited approach boundary. Completely gone because it didn't trigger anything. Remember that limited approach boundary triggers no unqualified people. Restricted approach boundary triggers we're going to have all of our PPE on, 1,000 volt rated tools, and the right category of meter. So both of those boundaries triggered something for us, and that's why the prohibited approach boundary was deleted. No trigger for that. Now we get to the tables that are going to give us an idea if we need arc flash PPE clothing or not. So these are the yes or no tables. The first one that I would like to take a look at is the normal operation of a circuit breaker. So to begin with, we understood back in Article 110 that to operate that circuit breaker normally, that it had to be installed properly, it had to be maintained properly. So those all those questions are now here. We see all these questions in this table now. So let's take a look at just the normal operation of a circuit breaker. The equipment was properly installed. You can see that there is an X underneath the word no. So, arc flash PPE required? Equipment was properly installed? No, I don't need to wear arc flash PPE in that case. Then we have to make sure that the equipment was the equipment installed properly. And if the equipment was installed properly, and then we're great. If the equipment was properly maintained, that's a key now. The equipment properly maintained. If the answer to that is no, which I suspect most of our equipment probably has not been maintained according to the manufacturer's instructions, if we answer the equipment is not properly maintained, if we answer that with a yes, you can see that now we are going to have arc flash PPE. So that to me is the key question. Has the equipment been properly maintained? And so when we revised this chart, you can see the equipment is not properly maintained. If the answer to that is yes, then we are going to have to wear some arc flash PPE. So if you believe your equipment has been properly maintained, hopefully you have that documented in accordance with the manufacturer's instructions. Otherwise, we're going to be putting on some arc flash PPE. To go on to that, let's come down to where it says for AC systems, work on energized conductors and circuit parts, including voltage testing. So they don't care about the equipment condition here. If you have exposed energized conductors or parts and you are troubleshooting, the X will always be under the yes column. You will be wearing arc flash PPE under that scenario. So a couple scenarios we want to look at. The equipment was properly installed. It was properly maintained. All the doors and covers are secured. All the original hardware is in place. No evidence of impending failure. We do not have to wear arc flash PPE in that instance. But if one of those things are missing, then we would put on arc flash PPE to operate that equipment. Of course, if we do have something exposed, we know that we do have some hazards present immediately there, and we would have to wear the arc flash PPE that we're going to look at here in this next slide. So these are the PPE categories. We understand that they did delete arc flash PPE category 0. It's no longer there. This table becomes very important when we do approach a piece of equipment and there is no label on that equipment. We are going to have to make sure that first we answer those questions. Do we need arc flash PPE? If the answer was yes to any type of particular equipment I walk up to, the next table we would go to is this table. And this table is going to be used in conjunction with some parameters. And these parameters have been in 70E since 2004. So if I walk up to a piece of equipment, and that piece of equipment is 240 volts and below, and the fault current is 25,000 amps or less, if the clearing time is 0.03 seconds or less, then I can use this table. If I cannot satisfy those parameters, I am going to have to do an arc flash risk assessment. So I would have to go to the analysis method unless I can satisfy these parameters. If these parameters are easily satisfied, then I can go ahead and use the arc flash PPE category method, and I can find out that I'm under 25,000 amps of fault current. My clearing time of my overcurrent device is 0.03 seconds or less. You can see that the arc flash PPE category would definitely be a 1. And so the next slide that I will show you will tell us what we're going to have to wear in arc flash PPE category 1. It also tells us the arc flash boundary. So we can see the arc flash boundary in this case would be 19 inches. If the and we'll see in a slide coming up, if the arc flash boundary is in excess of the limited approach boundary, that would be where we would put up our barricades or tapes or cones to keep the unqualified people away. So this table is going to be used in conjunction with the previous table. If that previous table, if we answered a yes, that we do need arc flash PPE clothing, then we are going to have to come to this table, and it would tell us what level of clothing we're going to be under for a particular type of equipment that we do approach. So you can see 480 volt equipment, the arc flash PPE category is going to go to a 2, and my arc flash boundary would go to 3 feet. So this table used in conjunction with the previous table, also in conjunction with the next table that I'm going to show you. Remember, these are snapshots of the tables. These tables do have much more equipment inside of NFPA 70E 2015. So the next table, again, they deleted arc flash PPE category 0, so we won't see that anymore. We do have to wear arc rated clothing according to the table method. Remember now that this PPE category method that we are looking at right now cannot be used in conjunction with the analysis method. This is a completely separate method. This method applies to when we walk up to a piece of equipment, it has no label on it, or they used the PPE category method to generate the label originally. So PPE category 0, we don't see, it's gone. PPE category 1, very similar to 2012. Arc rated clothing with at least a 4-cal rating, long sleeve shirt, long pants. If we do go outside, we might need some rain gear. That's why we see in parentheses the letters AN, as needed. Also have to wear the hard hat, safety glasses. SR means select one or the other. So you're going to have to either wear glasses or goggles. Those would be Z87 eye protection for us. We do have to wear the ear canal inserts, so we can't wear the muffs. Can't have the muffs on our head. We have to wear those. And notice that it does say heavy-duty leather gloves in 1 and 2. It says heavy-duty leather gloves. When we get to PPE Category 3, no longer are we going to see heavy-duty leather gloves. We are going to see arc-rated gloves. So this is talking about our leather protectors that go over the rubber insulation. Those leather protectors will have to have an arc rating on them when we are above 8 calories of energy. So if we get above a level 2 PPE category, we're going to have to go with some arc rated gloves for 3 and 4. Now this system only goes up to 40 calories. So as long as you could satisfy the parameters that we saw in the previous slide. So I'll give you an example of one. We'll take an example of switchgear right here. And if we satisfy this parameter under 35,000 amps of available fault current, and our clearing time is a half a second or less, then we would be in PPE Category 4 with an arc flash boundary of 20 feet. So if we come to this slide, we see PPE Category 4. This would be a full-blown flash suit, and we would have to have those arc-rated gloves on in conjunction with that flash suit. So this method, remember, this method is only going to be used if we did not do the full-blown arc flash risk assessment. Okay. They also changed the requirement for 1,000-volt rated tools. This has been changed to the restricted approach boundary in 2012. If we entered the limited approach boundary, which was at 42 inches, and it still is at 42 inches for most of our equipment, then we had to have 1,000-volt rated tools in our hand. But in reality, that limited approach boundary was really to take a visual look at something. It really wasn't to go in and interact with that equipment too much. The restricted approach boundary, now we're near 12 inches. We are going to be taking covers off. We're going to maybe adjust the torque setting of a piece of equipment. So that's where the 1,000-volt tools would come in. So restricted approach boundary is going to trigger now also 1,000-volt rated tools for our equipment. Barricades, very, very important. The barricades cannot be placed closer than the limited approach boundary, but if the arc flash boundary is greater than that limited approach boundary, then the barricade cannot be placed closer than that. So remember that the limited approach boundary is a shock protection boundary. They're trying to protect that qualified electrical worker from shock. The arc flash boundary, we are trying to protect that electrical worker from heat. So that's a boundary that would either come off the tables that we see inside 70E if we're going to use the arc flash PPE category method, or it's going to be a boundary that is going to be generated from the software if we do the analysis method. So that arc flash boundary, because it is a calculated boundary, many times it is outside the limited approach boundary. So we're going to have to keep those unqualified people away from that, because we do not want them inside an area that could cause them third-degree burns in case of an arc flash or arc blast. A new section that we are going to have to do a risk assessment. This is also in Chapter 1 in Article 130. Before we do any cutting or drilling into the equipment or into floors or walls or any type of structural type of an environment, if there is a likelihood of contacting energized electrical equipment. So we've got to perform a risk assessment. I'd love to use this example. A qualified electrical worker was fairly knowledgeable about this particular motor control center, and they decided to take a hole saw and they were going to drill through the outside metal to go ahead and maybe install a connector of whatever size. Well, what they did not realize was how that motor control center was constructed, because behind the piece of metal that they were actually drilling was a chase for the conductors that feed that MCC. And when they drilled through there with a hole saw, there was a major arc flash that caused damage to the MCC and injured the worker to the point where he could not come back and work in that same capacity anymore. So this is very important. We'll drill through floors, walls, especially walls, and we make no assessment there. Well, I've seen people drill through service entrance cable that's not even protected by any overcurrent device because they didn't do a risk assessment. If your facility has a thermal imaging camera, very easy, we can take a infrared scan of that wall, give us a really good idea what might be behind there. But we are going to have to do a risk assessment before we do any drilling, and that's going to be very important. Also, there's some clarification here on who is responsible for maintenance of the electrical equipment. Not just who's responsible for installing the label, but also who's going to do all of the maintenance that now 70E requires, and that maintenance, of course, in accordance with the manufacturer's instructions. It is going to be the owner of that equipment or their designated representative. So what does that mean? If I, let's say, am going to do some maintenance on equipment at a strip mall, and there's multiple stores in that strip mall, well, you know, the owner of that strip mall really, he does not know what maintenance should be performed on that electrical equipment. So he's going to designate somebody. Maybe he'll designate his outside contractor to perform that particular maintenance. And that's fine. He can do that because he's not a person that is familiar with electrical installations or how we perform electrical maintenance. So he could designate XYZ contractor to do that maintenance for him. But it is that owner's responsibility. In conjunction with this, we should understand that the National Electrical Code, which is NFPA 70, and NFPA 70E, which is the safety document we're talking about now, they go hand in hand with also NFPA 70B, which is electrical maintenance for our electrical equipment. And the new revision of NFPA 70B wants us to have another label on our equipment. And that label is going to be a reflection if the equipment has been maintained properly over the years. So if we see, for instance, if we see a white label that is pertaining to maintenance, that white label would give us an idea that the equipment has been maintained properly for the life of the equipment. We can go ahead and work on that equipment normally and should have no problem whatsoever. Or maybe we see a yellow label on that equipment. Maybe that yellow label would indicate, we've got a broken window or whatever that we've put in our preventive maintenance program. We're going to take care of that, but there's a minor deficiency there. Or possibly we might see a red label on the equipment. Maybe there is a 4160 volt breaker that was installed back in the 40s. It has never been turned on or off for the last 74 years, and it may be time to perform some maintenance on that. We're going to have to take that out of service. They don't want us to do anything energized with that. We would put a red label on that. So those labels are all independent of any labels that are required by 70E. That label is now a label that 70B would like to see on that piece of equipment to give that qualified worker an idea. Can I operate this equipment really normally? I can come up and operate it, turn it on or off with no PPE because it was installed properly, it was maintained over the years. Or if it hasn't been maintained, hey, I'm going to have to go and get some PPE on here to protect myself because who knows what's going to happen when I turn this on or off. So the maintenance of the electrical equipment has been stressed very heavily in this edition of 70E. New maintenance requirements for our meters. So our test leads, we're going to have to make sure this is in our electrical safety program. We're going to have to document that our meters have been calibrated, that they've been given a test, that they actually do work in all of their functions that they have, and that the leads have been also verified that they've been maintained properly according to the manufacturer. And this falls under Chapter 2, which is our maintenance requirements in 70E. Also states that meter is part of our personal protective equipment. It's the only way we can verify the absence of voltage. So we should be maintaining our meters and test leads in accordance with the manufacturer's instructions. They are also going to tell us that all these leads have to be inspected for any kind of damage before each use. The meter is going to have to also be given a visual inspection. If there is some, let's say, malfunction with that meter, it's going to have to be removed from service immediately, and it is going to have to be sent back to the manufacturer to be calibrated again and repaired so that we can use that particular meter again. So very important that we're doing maintenance with our meters and test leads. This they're going to want to make sure that we do this once every 3 years. We're going to have to document this has been performed. So we're going to, the meter is really the only tool in our hand that we can establish that electrically safe work condition with. Extremely important that we maintain it according to the manufacturer's instructions. New section up in Chapter 3. What we want to remember about Chapter 3, this is special equipment. This is talking about storage battery rooms here. We are going to have to do a risk assessment before we do any work on a battery system. We've got to make sure we understand what chemical is being used, what type of voltage is there so we can protect ourselves from shock. We ought to have a little bit of idea if the batteries have been maintained properly. So any risk, I would also throw in there to make sure that the air has been circulated properly in that room before we allow a worker to enter that room. So Chapter 3 deals with all of our special equipment. Lasers would be in Chapter 3. Electrolytic cells, research and development labs would be up in Chapter 3. Also, we would see our power electronic equipment, VFDs, would be up in Chapter 3 also. So those are the major changes, and just want to know that American Train Co. is right now conducting seminars on the 2015 70E. We will come to you. We will do in-house training. We have many public seminars that we're doing. We do over 2,000 courses each year all over the United States and Canada. Our instructors must be doing a pretty good job. They've been given a pretty good approval rating, so American Train Co. has been doing a lot of things there. I know that Kellen is going to open up this to questions here shortly, but if you have a question maybe after this, and maybe it's a question that might be fairly extensive, my email address, robertjc@americantrainco.com. I think this is the fourth webinar that I have conducted, and I can tell you that after the fact, I get many questions and some great questions from people. So if you have any question at all, either about American Train Co. or technical content, go ahead and send me a quick email. So at this time, I'm going to turn it back to Kellen, and we will entertain any questions that you might have.
Thank you, Bob. And as a reminder to all participants, if you'd like to submit a question to our speaker at any time, please click into the area in the bottom of your screen, type in your question, and then hit the Send Question button. Also, as a reminder to our participants, we've posted today's slides in a link in the text chat area. If you just click on that text chat window, you will see the link to download today's slides. And we do have several questions in queue, Bob, so I'll just jump to the very first one here. Our first question is, I have a question about the elimination of Category 0 for a cabinet panel that was a Cat 0 with an arc boundary of 9 inches, for example. Is it now no PPE required, or is it a Category 1?
That's a great question. And so with the analysis method, it is going to be a PPE Category 1. Well, here's what we got. Here's what we can't mix and match those two methods. So what we're going to do if the analysis method was used to generate that label, PPE Category 0 should never have been on that label to begin with. We cannot mix and match those. All we should see with the analysis is incident energy. And if we see incident energy below 1.2 calories per centimeter squared, then basically there's no arc flash PPE required. We would have to go ahead and protect ourselves from shock hazard, but those PPE categories are really dealing with only arc flash. So they're dealing with the heat. And when the heat is below 1.2 calories per centimeter squared, that is basically a safe amount of heat, and that's not going to cause our clothing to start burning. So with the analysis method, you're not going to see any PPE category on that label at all. With the table method, you don't have to. You just have to say no arc flash PPE required. Protect yourself from shock. But so I hope that answers that question, because when that question was asked, it's mixing the two methods, and we can't mix those two methods anymore. That is done. And so as we review these labels, if we see that the arc flash PPE category was associated with an incident energy level, we're going to have to replace that label. So if it's the analysis method, all that label is going to tell us now will be how much incident energy is there. It's probably going to be below 1.2 calories, which cotton clothing would take care of, no problem. And with the table method, all we're going to have to say on the label will be no arc flash PPE required, because the energy is so low.
Thank you. And our next question is, auditing, is that more than periodic to OSHA standard?
Yes. So the auditing of the field work is now going to be a 1 year. Although it depends if we're in 1926 or 1910, but a lot of OSHA's fieldwork auditing, a lot of that, let's say, for instance, lockout-tagout auditing. Now, OSHA wants to see lockout-tagout auditing every year. Now, this fieldwork auditing, we're probably not going to see that in 1910 really at all. So in 1910, we would see something about lockout-tagout, but as far as the safe work procedures, in 1910 we really wouldn't see any auditing, so this is above and beyond what OSHA would require.
Thank you. And our next question is 70E training only good for 600 volt and less? At what point is high voltage training necessary?
Okay, so 70E does, they cover medium voltage. Some of the tables in 70E go way above 35,000 volts. So, and what we have to understand now is that cutoff, that demarcation point, really is at 1,000 volts. The 2014 edition of the National Electrical Code has raised that level to 1,000 volts. And I, as an employer, I would really make a distinct separation here, because above 1,000 volts, we are going to have to really have some qualified electrical worker training to go along with 70E. So 70E does cover above 1,000 volts. There's no question about that. But there's going to have to be some very specific training in association with that voltage. So they are going to have to be trained. 70E does not stop at 600 volts. So that worker that's above that does work above 1,000 volts would have to be qualified for that voltage. So he would have to be trained in many things that a worker below 1,000 volts would not have to be trained in. But 70E does cover both. So we are going to have to train that worker in the requirements of 70E. The tables, as far as the shock protection tables, those will go up to 46,000 volts, 75,000 volts. So, but it will require also some additional training to make sure that not only does that worker understand the requirements to do risk assessments and to keep themselves safe, but what personal protective equipment and special procedures are needed when they go above that 1,000 volt range.
Thank you. And our next question is, per slide 15, can electrical equipment be brought up to date with proper maintenance if it has not been properly maintained in the past?
Yes. So if it has not been properly maintained in the past, I would go ahead and have a representative from the manufacturer of that equipment come in, give me recommendations, document it on how I can get that piece of equipment to the proper maintenance condition of 2014, October 15th, which we are today. So in conjunction with the manufacturer, I would have the manufacturer come in. He would do an assessment of the equipment, give us an idea of exactly what has to happen to make that equipment to be in perfect condition as far as today is concerned. But I would not attempt to do that without manufacturer involvement and documentation.
Thank you. And our next question is, does normal operation apply to voltages other than 120 volt, i.e. operating a 4 kV, I think, breaker from the operating switch on the enclosure door?
Sure. Normal operation of electrical equipment is going to apply to every piece of electrical equipment that we have out in the field today. So we have to take a look at, and I gave an instance of that 4160 volt breaker that had never even been exercised in 41 years. So normal operation is not going to be limited to any voltage. It is going to be for every piece of electrical equipment we have in the field, and to be able to operate it normally, it is going to have been properly maintained over those years, properly installed, all the covers in place, no evidence of impending failure. All those conditions will have to be satisfied before we can operate it normally. Of course, we can still operate it with the protective, personal protective equipment on or other procedures. I have seen people put a pulley on a piece of electrical equipment and tie a rope to the handle and be 50 feet away to turn something on and off, well outside the arc flash boundary. So there are some scenarios where we could brainstorm and, all of a sudden we're going to operate that equipment, but we're not operating it normally anymore. We're operating in a way that, consensus has come up that this is going to be safe. It's not normal operation, but we can get it to work the way we want in a safe manner. But if we want to operate it normally, voltage does not apply. Nothing applies there. It's just any equipment that's out in the field.
Thank you. And as a reminder to all participants, you can download today's slides by clicking on the link in the text chat area. Just click the text chat box there at the bottom of your screen, and then you should be able to access the slides via the link. You may need to copy and paste that link into a separate window. It might make it a little easier. Looks like our next question is, in NFPA 2009, limited approach was for unqualified workers, restricted approach was only for qualified workers, and prohibited approach is where shock PPE was required. Can you speak to more clarification on this deletion of prohibited boundary?
Sure. So in 2012, those boundaries, the triggering statements changed a little bit. So in 2012, the limited approach, basically, no unqualified people could go in there without being supervised. So if we had a qualified electrical worker that was going to supervise an unqualified person and they had the proper PPE on, they could go in there and take a visual look, and that was in 2012. In 2012 also, the restricted approach was basically, I better have all the proper PPE on, 1,000-volt rated tools, the right meter. In 2012, prohibited approach, the definition said, making contact. That was about it. It did not really trigger anything. I mean, the distance was 1 inch in 2012. Well, when you're 1 inch from the electrical equipment, you are pretty much taking a voltage reading. Your hands are 1 inch away from exposed energized conductors or parts. Your meter is making contact with the equipment, but it really didn't trigger something that I had to maybe put more PPE on or keep people away. I'm already keeping them away. So in the minds of the technical committee, they said the prohibited approach boundary really, as far as the 2012 version was concerned, did not trigger anything new. So they deleted the prohibited approach from the 2015 version, and now we have just limited and restricted. Remember, there's shock protection boundaries. The limited approach will still trigger no unqualified people in that area, and the restricted approach will trigger all the proper PPE and tools and metering equipment in my hand.
Thank you. We still have several questions in queue. Our next question is 70E a globally enforced standard?
No. 70E is only enforced in the United States. Canada does have Z462, which is very similar to 70E. But I will mention this. There are many companies out there that work in the U.S. and around the whole world. So a lot of those companies are enforcing 70E internally. They want to protect their workers no matter what country they're in. So some of the major companies that are working worldwide enforce 70E throughout the whole gamut of their operations. And but worldwide, it is not enforced by other countries. No.
Thank you. And our next question is, according to NFPA 70E 2015, can we use arc flash rated gloves for level 2 or 1 for disconnect or switch operation with doors secured?
Yes, sir. So that's a great question. So if we want to purchase arc rated leather protectors, we can use those for all of the PPE categories. And if we're using the table method, if we're using the risk assessment method as far as the analysis is concerned, then we certainly can use the arc-rated gloves for the rating of the arc-rated glove. I know I have a pair that are arc-rated at 22 calories. So if I'm using the analysis method, then they would be good up to 22 calories. But I could have bought a higher rated glove for the analysis method, but I just chose to only work on 22 calories, that's all. But that's a great question. Yes, you can use those gloves.
Thank you. And our next question is FR-rated protective clothing needing to be replaced, updated to AR?
That's a great question. So that was a concern in the 2012 version. I know a gentleman by the name of Hugh Hoagland submitted that change for us. And really what you have to look at is the tag on the clothing. So what he was finding as he was testing some of this clothing was that it did not have an arc rating on the clothing itself. So if we look at the different types of clothing, and we have a lot of different choices out there today, some of this clothing is made for firefighters. Some is made for welders. Some is made for electrical workers. Well, the clothing that is made for electrical workers definitely has to have an rating on there in calories per centimeter squared. So if you see 10.1 calories per centimeter squared on the label of the clothing, then you know it is arc rated. If you and so it doesn't matter if it was advertised as FR or AR or anything else. If there's a calorie rating on that clothing, then it was built to the ASTM standard, and we can be assured that it is a clothing that does protect the qualified electrical worker. But what we have to remember is some of this clothing is only made for NASCAR or whoever. So we have to see a calorie rating on our clothing. And I don't care if the clothing says FR, AR, or any R in the whole world. If it has that rating in calories per centimeter squared, then you can rest assured that it is going to protect that worker for the rating that's on that clothing. Whatever that number is on that clothing, it will protect that worker.
Thank you. And our next question is, could you cover electrical integrity testing of switchgear per OSHA 1910, i.e. need to test switchgear every 5 plus or minus years?
Okay, so that switchgear, in 70E, it really doesn't address that particular requirement. It just says this, that the switchgear has to be maintained according to the manufacturer's instructions. So we've got to get back to the manufacturer on that switchgear, and we've got to perform the testing that the manufacturer recommends. So personally, I would have some documentation from that manufacturer, all of the procedures that they use, their testing procedures, their requirements, have that documented, and that would be my method of how to go ahead and test that switchgear. Because we got to remember that the OSHA requirements are kind of vague. They don't know the type of switchgear that you particularly have. So if we want to be in compliant with that, we want to go ahead and get back to the manufacturer and have some specific procedures to go ahead and test that gear.
Thank you. And our next question is, so then panels and equipment with only 120 volt and below, no arc-rated PPE will be required?
We have to make sure that there's no other voltage inside that panel. And right now, the way that the table is, if we use the table method, it says 120 volt control circuits. So I believe that coming up in 2018, we might just see just regular 120 volts and nothing else present. The consensus on this thought is that 120 volts, there is not enough pressure behind that circuit to sustain an arc through the air for a long enough period of time to cause an arc flash or an arc blast. So right now it says 120 volt control circuit panels. We don't need any arc flash PPE on our body. I think that might be expanded in 2018 a little bit too. Every place that it says 120 volts, but we've got to be very careful because in some of our industrial equipment, we might see 480, 120, and 24 all in the same enclosure. Then we would have to protect ourselves to that higher energy that we'd be exposed to.
Thank you. And our next question is, do existing labels that are under older 70E versions have to be revised and replaced, or are they grandfathered in at the time of the study?
Okay, so what 70E 2015 tells us that when we review our arc flash assessment, if in fact we make a determination that that label is no longer a valid label, they want us to update that label. So my opinion is that you really cannot have a PPE category level and an incident energy number on the same label. That's like mixing apples and oranges together, and it just can't be on that same label. So very easily that should be able to be accomplished by eliminating the PPE category that got put on that label initially. So, hey, a permanent marker could just delete Arc Flash PPE Category 1. It could delete that. And then you just have on there the incident energy. And that's what we'll have to protect that worker against, is the incident energy. And there's a lot of ways to do that other than those PPE categories that we list out in the table method. So I think that could be done very easily, and but you also want to be looking at those labels for other things also, making sure that that incident energy is a good number related to the arc flash boundary. I've seen some arc flash boundaries which might be 11 inches, and then I look at the where the energy was measured, and the energy at 18 inches, let's say, was 1.8 calories. Well, how can how can the arc flash boundary be at 11 inches? Because as you get closer to the equipment, then that incident energy is going to go up. So you've really got to take a close look at those labels and make sure that the PPE category and the incident energy is not on the same label, and that the incident energy really matches up with the arc flash boundary, so that they're going to measure that incident energy. If the voltage is 600 volts or below, they're going to measure that at 18 inches. If it's above 600 volts, they're going to measure that at 36 inches. And just make sure the arc flash boundary does match up with where they measured the incident energy level. So that's important. And then make sure that the PPE category is not on the same label where the incident energy is deemed out to us.
Thank you. And our next question is, still confused on the arc flash PPE category analysis, calorie and table method. Sure. Are you saying that the two types do not work together?
That's correct. So in 70E, it specifically states you use the analysis method or the table method, but not both. So you cannot put that information on the same label. You can't use those two methods to try to protect your electrical worker. It's going to be very confusing, and this has really been in 70E since 2004. We never should have been doing this. A lot of the software that's out there did include these two methods when they went ahead and generated those labels. So it was real tough to get to the point where the committee wants us to be, which the committee wants us to be either one of these two. I either see a number on there in calories per centimeter squared, 22, and that's all I see. Really, there's three things that have to be on that label: the voltage, the arc flash boundary, and the calories. That's really the only information that has to be on the label. Or if I decide to use the table method, I'm going to see the voltage, the arc flash boundary, and a PPE category. But I am not going to see a PPE category and a calorie per centimeter squared number on the same label. That's mixing the two different methods. and they do not want that to be on the same label. We can't do it. It's two different methods completely, and they spelled it out in this edition of 2015 70E. They want us to be 100% positive that we understand that we're using either calories per centimeter squared or a PPE category, but not both.
Thank you. And our next question is, our EH&S folks are requesting us to perform an arc flash risk assessment on our leased facility, office and light manufacturing. Who do you suggest we contact to perform this assessment? Okay,
so there's a lot of companies out there that are doing these assessments, and personally, I want to say this: if you're very familiar with maybe other companies that are close in your geographical location, ask them if they've had this assessment done, and if they're very, very pleased with the results of that assessment, and maybe get some bids and ask for samples of labels. And so depending on the part of the country that you're in, you're going to have a lot of choices on engineering firms that perform these services for you, and get some multiple bids, get some recommendation and some references, look at some sample labels, use my email, send me a sample label, let me comment on it, I'll send it back to you. But I want you to feel very comfortable with the person that you choose, and a lot of that is going to come from references. So try to get a company in your area that has already performed the labeling requirements that are required in 70E. Ask them for a sample. Ask the person that did it for a sample, and build a relationship with the person that's going to perform those studies for you. And once that has done, I think you're going to, finally choose an entity that will do a great job for you. Also, my personal belief is this: that it's really not just a study, that there has to be some things incorporated with this label as far as training goes. What does the label really mean? How can I satisfy this label in a way that my worker is not going to be constrained with a lot of PPE that maybe he might not need? So some training would be in conjunction with the label also, and then make sure that worker can demonstrate that they're going to be safe when they approach that equipment for whatever task that they are going to be performing.
Thank you. And our next question is, will you do this presentation for private groups?
Yes. Our presentation with 70E is really based on either, it depends. We've done our standard 2-day presentation for groups, which we go into this with so much more detail than we are now. We actually have people practice the table method with labeling. We talk so much about fault current and how it's going to have an impact on the amount of energy that's going to impact the worker. We'll do a standard 2-day. We do a 3-day with a hands-on component of it, where that qualified worker has now been changed the definition to demonstratable skills. We give a written test that they understand the information that we presented. We also do hands-on component where they have to perform an electrically safe work condition. They have to do a little bit of troubleshooting for us. So we'll do a standard 2-day or a 3-day, or then we can do also some presentations that might even be a combination of the two. We've done 1 day or a 2-day with some of the 3-day component inside. So the slide that just came up is going to help you with that tremendously. If you email sales@americantrainco.com, we have some people here in Denver that can give you quotes on that, and we can be at your facility for whatever amount of time you allow us to be there. And those on-site presentations are so powerful because we can take a look at your equipment and give you an idea exactly what you need to keep your employees safe.
Thank you. And we have a few more questions in queue here. Our next question is, how do we know if FR&R rating clothing is no longer protective?
Oh, that's a great question. So depending on the material that clothing was made out of, the manufacturer actually gives you a lifespan of that equipment and how many launderings that equipment can handle. So a lot of different types of equipment out there as far as PPE is concerned: Nomex, Endura, PBI Gold. So a lot of different types. And now we've got to go to the manufacturer of that equipment, and we've got to make sure, one, that we are laundering it properly. We are going to have to make sure that we do not go on past the lifespan of that clothing. Some things that we should look at on a daily and weekly basis: loose threads, holes, patches in the clothing. Any of that stuff would render that we take it out of service and we have some new clothing provided to us. But the manufacturer does give us some very specific parameters on the life and the laundering of that equipment. So we've got to be very careful who we choose to launder that equipment and if they are following the manufacturer's instructions.
Okay, and our next question is, how is certification of electrical test equipment required according to NFPA 70E, and who should provide this certification?
Okay, so that's great. So test equipment, it can be certified by the manufacturer, or that can be done by many different testing agencies that are out there. So there's a lot of testing agencies that can come in and calibrate your meters for you. They can certify them for another 3 years, 1 year, whatever the manufacturer recommends. So you can do that in a variety of ways. Many people use the manufacturer themselves of the test equipment, but you know, there's some independent people that will go around there. I can remember being at a facility, they did it in-house. They actually hired a person that had worked for a company that certified meters, and then that person went ahead and made sure that every meter that they had in-house was perfect, up-to-date, calibrated, ready to go. Megged out the leads, made sure the leads were properly in good working order. So you can do it in-house if you have a qualified person to do that. You can send it out to the manufacturer, or you can have a private company come to your facility, and they will go ahead and certify all your meters and leads.
Thank you. And we have a little bit more time here for a couple more questions. I have our next question is, are leather outer protectors not typically arc rated, and therefore do we need new leather gloves? That depends.
That depends where you buy it from, and if you specify that you want them arc rated. So, depending on where you buy your leathers from, and if you're using let's say the table method in PPE Category 1 and 2 just says you need leather protection for your rubber gloves underneath. Until you get to PPE Category 3 and 4, then they want those to be arc rated. With the analysis method, I would have them always arc rated, and it would be above the number that is on the equipment that I'm working on. So when you go ahead and buy those leather protectors, I would ask the manufacturer or the supplier, please make sure that I get the leathers that are arc rated. And I will tell you, the ones that we use, they are so pliable and they're so user friendly, and they're arc rated for 22 calories. So, you know, I just don't see why we wouldn't be buying the arc-rated ones, because now they're going to protect us from some heat energy. Also, they're going to protect that rubber underneath from getting any holes in it. So the arc-rated leather protectors, in my opinion, are a way that we should really go.
And thank you. Due to time constraints, this will conclude our question and answer session. This time, I would now like to turn the call back over to you, Bob, for any concluding remarks.
I want to thank everybody. What some great questions that you did ask during this presentation. Also, if you have more questions that I couldn't get to, go ahead and send those to my email. If you have a question about training, you can send it to sales@americantrainco.com, and we would be more than happy to appear at your facility or hopefully see you in one of our open seminars, which we conduct in every major city every week of the year. Thank you so much. A very important topic, and I'm glad that the awareness has risen to the level that it did today. Have a great day and enjoy the rest of your week.
Thank you all for your attention. This concludes today's conference call. All participants may now disconnect.